The orbits of the planets were understood with extraordinary precision, with one exception. Mercury's orbit shifted slightly, unaccountably, every year.
It's a very small number, previously totally unexplained. Now here, on the basis of this theory, which he had invented out of nothing in a certain sense, out of his view of how God would have had to make the universe to make it right, he's able to calculate this very real, small effect and get the right answer. That could give you palpitations.
And I believe at that moment, Einstein said, I don't care what the world will say. I am right, because the Lord has told me, calculate the perihelion motion of Mercury, and you will see. And he did, and it came out.
When I found that my calculations predicted the motion of Mercury exactly, something snapped inside me. The feeling was so extreme. I couldn't work for days. I was beside myself. In all my life, I never felt such joy.
The calculation vindicated Einstein's radical idea that space-time is curved. Mercury, the innermost planet, shifts its orbit as it travels around the dent in space and time created by the sun's huge mass. Mass everywhere deforms the space around it. Even light, as Einstein had recognized years before, must follow all the curves in space and time, mapping the shape of the universe as a whole. It is this understanding that drives the scientific story of creation. The Big Bang, the expanding universe, the structure of galaxies, the great sweep of modern cosmology derives directly from this single equation. Space and time on the left, matter and energy on the right. This is the general theory of relativity, Einstein's theory of gravity.
General relativity is in a class all by itself. We are just stunned, even decades later, that he could come out with that theory back in 1916. I would say he was 50 years ahead of his time.
You're muted.
Give yourself the points. Newton's theory worked fine, with the exception of the orbital motion of Mercury. There was a slight deviation from what was predicted, and no one knew how to explain it. And they thought that there was an exoplanet within the solar system. And with the addition of the exoplanet within the solar system, they could explain that little deviation. And so they called that planet that they were looking for the invisible planet, or yet to be discovered planet, Vulcan. How many of you guys know what Vulcan is?
It's a Roman god, right?
Okay, that's a Roman god. I'm going to give you 5 points for that one. On top of that, all right, guys, you need to dig in harder. What else? There's someone who's from Vulcan. Does anybody know who that person is?
Yeah, my great-grandfather was from Vulcan.
I doubt it. Who else is from Vulcan?
Is it Spock?
It's Spock. Give yourself 20 points for that one. That's worth more than the Greek mythology. All right, so Spock from Star Trek is from Vulcan. All right, so they were looking for it, so no planet was found. And then Einstein looks at it. He says, wait a minute, if my theory is correct, it should be able to actually correctly replicate the motion of Mercury, which it does. All right, so that was the first proof that his theory was correct. All right, now this guy, Einstein, is interested in further verification. And according to the history, here's what happened.
But the spring of 1919 was special, even for him. A silent film explained Einstein's breakthrough to the public, with animation by Max Fleischer, creator of Betty Boop. General relativity predicted that starlight passing close to the sun would curve around the warp in space-time created by the sun's mass. That bending of the light would make the star seem to occupy a new position in the sky to an observer on Earth. This could only be seen during a total eclipse of the sun. A British expedition traveled to the South Atlantic in 1919 to photograph an eclipse. It would be the first public test of Einstein's theory. May 29th dawned overcast over the Atlantic. But then the sky cleared. And in the shadow of the eclipse, light warped around the sun. Gravity bends light exactly as Einstein had predicted.
What would I have thought if the English had found nothing? I said at the time, I would feel sorry for the dear Lord. The theory is correct. For me, general relativity was simply too beautiful to be false. It was inconceivable that the English would come back proving me wrong.
The eclipse results were announced in November. Literally overnight, Einstein became world famous, the first scientist celebrity of the 20th century.
You're muted again.
All right, Matthew, you're in charge. All right, this says almost like the Wikipedia version of what took place in history. The real life was slightly more complicated, as it so happens, involving these two guys. In 1919, there were 2 expeditions. One of them was conducted by the guy on the left. His name is Eddington. and the other was conducted the year before or 2 years before by the guy on the right. His name is Campbell. All right, so there were 2 expeditions regarding 2 different eclipses. Pictures were taken. Addington said Einstein's theory is proven, and Campbell said there's no such thing. All right, so in 1919, there was a draw. All right, so one set of data actually proved Einstein correct. The second set of data said, nope, they did not see any deviations regarding the locations of 92 stars predicted by Einstein's theory of gravity. All right, so light following the curvatures of space-time continuum is supposed to bend around the sun, so the stars are supposed to occupy a different position predicted by the theory. So it was thought that one of them ended up fudging the data. All right, so results of this observation. So do you think that the guy on the left or the guy on the right ended up fudging the data? So Eddington came up with the observations that proved Einstein correct, and Campbell came up with observations proving that there was no deviation, which meant that the Einstein's theory was wrong. All right, so guys, we will get to judge our book by its cover at this point. All right, so I don't know if it's going to help you, but you will have to make a decision. All right, so the Eddington's data proved Einstein right. Campbell's data proved Einstein wrong. Eddington is British. Campbell is American. So having said that, whose results do you favor, Eddington or Campbell?
Addington,
Why?
because we still use Einstein's theory.
Man, Ian, we were talking about the first set of observations.
I like Campbell because he's American and I'm patriotic.
Okay, so I like that answer, yes. All right, Ian, what the hell is wrong with you?
All sorts of things.
Okay, so why did you like Eddington immediately? You like his glasses or something?
No, I mean, as someone who's 1/8 Vulcan, I've always identified more with English. Also, I figure if they had proved Einstein's theory wrong, we wouldn't still be using it. I suppose they could have both been wrong.
Okay, so here's the problem. Addington and Campbell, they came up with a set of data. Addington said Einstein is right, so he did the evaluations and everything else. And Campbell said Einstein is wrong. All right, so why is it that the data is so contradictory? That's number one. And believe it or not, most people thought that Eddington is the one who fudged the results, not Campbell, especially in the United States. And this has nothing to do with nationalism. All right, so remember, guys, 1914 to 1918, there was Great War, which we today refer to as the World War I. And for those of you guys who don't know, Einstein was a pacifist. So was Eddington. All right, so Eddington is British. Einstein is supposedly German. And obviously Germany and England were at odds with each other. World War I, World War II is the same thing. So World War II is the sequel. And then so they thought that the Eddington ended up fudging his results to actually promote a fellow pacifist from Germany to prominence. And that's what they thought initially. And they had every reason to think so too, because things happen. History of it is actually really, really fascinating. All right, let me just find this.
Some people wonder, how did Einstein think?
I think
How
we're on
did
the
physicists think?
All right. Okay, we're not on the
If
same page.
Einstein's theory is right,
I'm looking at all those slides from the PowerPoint.
Okay, so we're not on the same page. Okay, so can you guys see it now?
Yeah.
All right, can you hear it?
or wrong.
Because there was a war going on, no one else could go. The Europeans couldn't send an expedition. And so he had the field to himself.
But Campbell also has a problem.
They didn't have their equipment because it was still trapped in Russia.
Campbell had been forced to abandon his state-of-the-art camera gear in the Crimea back in 1914 when World War I first broke out. So he improvised.
It's kind of weird because Campbell actually has been trying to prove Einstein correct. Einstein publishes his earlier version in 1913 and whatever, and there's some predictions, and Campbell goes to Crimea. And obviously in 1914, the World War I starts, and he gets arrested as a spy. So he was able to barely leave the country while leaving his equipment behind.
Campbell went scrabbling around for equipment.
Campbell is down
at the
American.
observatory. They got a lens here, a tube here, and they cobbled together a couple of cameras for Golden Dale.
The Lick Party was forced to use substandard equipment.
Campbell has no choice but to take the risk. He has a total solar eclipse all to himself and may never have another opportunity.
It was weird.
Some people
Alignment may not wait for the war to be over. The next full eclipse will occur in June 1918, and it won't be visible in England, where Eddington is trapped by war. However, it will be seen in the state of Washington, practically in the backyard of a man who has been down this road before, William Wallace Campbell of California's Lick Observatory.
There was going to be another eclipse in 1918,
not very far from the observatory in Goldendale, Washington, in the west.
If Campbell succeeds in photographing this eclipse, he can be the first person to determine if Einstein's theory is right or wrong.
Because there was a war going on, no one else could go. The Europeans couldn't send an expedition, and so he had the field to himself.
But Campbell also has a problem.
They didn't have their equipment because it was still trapped in Russia.
Campbell had been forced to abandon his state-of-the-art camera gear in the Crimea back in 1914 when World War I first broke out. So he improvises.
Campbell went scrabbling around for equipment in Lick Observatory. They got a lens here, a tube here, and they cobbled together a couple of cameras for Goldendale.
The Lick Party was forced to use substandard equipment.
Campbell has no choice but to take the risk. He has a total solar eclipse all to himself, and may never have another opportunity like this again. Campbell's party travels to Goldendale, Washington, and gets ready for the coming eclipse.
It was close to home, so the whole family went.
Campbell's goal is to photograph the stars that emerge in the brief period when the sun is hidden by the moon. But on Saturday, June 8th, 1918, it seems that the universe is once again not ready to yield its secrets.
Clouds moved in, and it looked like he wouldn't even get observations, and Russia would be repeated, which he hated. And suddenly, just at the crucial time, when they needed a clear sky, the clouds parted.
Campbell begins taking photographs of the spectacle.
It starts when the moon first comes in contact with the sun and then starts to move over the face of the sun. The sun becomes smaller and smaller and smaller until the last moment when the sunlight actually passes through the valleys between the mountains of the moon. And then this bright, brilliant beam of sunlight, and then the sun is entirely eclipsed. It's the blackest black you will ever see. My first eclipse, I literally lost my breath. It was like jumping in cold water where you go, you can't believe it. It is breathtaking, literally breathtaking. It's a gorgeous sight.
It's just, wow, most powerful experience that I've ever had in my life.
The New York Times had a reporter, and they wrote an article, "Clouds Fall Away for Eclipse." There's a little subtitle, "Test of Einstein Theory." This is the first time that an American newspaper mentioned Albert Einstein.
Campbell assigns his most trusted astronomer, Heber D. Curtis, to analyze the photographs to prove or disprove Einstein's theory.
Looking in, a star would have been visible, one of the stars that was to be measured. That star would have been very carefully centered on crosshairs in the eyepiece. Once that was done, the scales could be read in the X and Y directions, and a very precise position could be assigned to the star. From those numbers, it could be determined whether the star had appeared to change position.
Einstein has predicted that the warped space around the sun will create an optical illusion, making the stars appear to move outward ever so slightly.
Einstein predicted much less than a millimeter. Well, this is not an easy measurement to make.
Unlike most theories that people put forth, Einstein's general relativity makes very specific predictions. Very tight, it's got to be this, and if it's not that, then the entire foundation of the idea has got to be discarded.
Extremely precise, painstaking measurements.
There was no wiggle room in Einstein's relativity because the idea that gravity is the manifestation of the curvature of space and time. You say how much it curves and what happens to matter or light in the presence of that curvature, calculate it, make the prediction. If the prediction doesn't come true, you don't go say, okay, let me see if I can tweak the theory. Not in this case.
You can see on these pages the kind of labor that Curtis had to endure in order to make these measurements. There's page after page after page of this. Some pages crossed out.
All you needed was one experiment to show that any aspect of relativity would fail. And he'd have to go back to the drawing board completely.
Curtis looks at the stars and sees nothing unusual. They all appear in their normal places, which can only mean one thing. Einstein is wrong. But Campbell is unwilling to risk his reputation on improvised equipment.
Nobody wants to reveal an answer until everything has been double-checked. The best tactic is total silence until you're absolutely sure what you found.
Campbell orders Curtis to check his results again and again. As Curtis works in quiet isolation atop Mount Hamilton, Europe is in chaos.
The order of Europe changed completely. We have three empires that disintegrate within weeks of each other.
On November 9th, 1918, Kaiser Wilhelm abdicates the throne. Einstein notes in his lecture book, class canceled due to revolution. In the immediate aftermath of the war, German scientists, including Einstein, are still not